Hello everyone, this is Deris Drill Bit. Welcome to our channel. We all know that in drilling operations, drill bit performance is crucial, which directly affects the efficiency and safety of the operation. Today, let's talk about the tricone drill bit, which is the most commonly used drill bit, but it also faces many challenges. First, let's look at the reasons for the failure of the tricone drill bit. The main reasons for the failure of the tricone drill bit include 1. The adaptability of the product to the formation. Crossing rocks of different hardness will affect the performance of the drill bit, especially in extremely hard or multi-mineral formations. It is more likely to be damaged. 2. Product quality. 3. Usage method. 4. Wrong operation. Next, let's take a look at the manifestations of the failure of the three-cone drill bit. Here we first use a simple structural diagram to quickly understand the names and composition of the various parts of the three-cone drill bit. The main forms of its failure are as follows. 1. Nozzle erosion. Repeated use of tungsten carbide nozzles. This situation often occurs if one or more nozzles are blocked. The nozzles that are not blocked are likely to be eroded due to the following reasons. 1. The sand content in the mud is too high. 2. The spray speed is too high relative to the nozzle size. If the nozzle is removed and reused, its inner diameter is likely to be enlarged or the nozzle inlet is eroded. 2. Broken tooth palm. Because the drill bit passes through a small well bore and is affected by the lateral force of the well wall. After the palm back is damaged, the bending moment on the palm is too large. The thermal cracks caused by the friction between the palm back and the well wall are the reasons for the broken tooth palm. Severe jerking and drilling slip may also cause the fracture. Hydrogen sulfide causes hydrogen embrittlement cracking. 3. Tooth loss/loose teeth. Broken teeth will cause cutting failure and may cause drill jamming problems. In most cases, it is because the fixing force between the teeth and the tooth holes is insufficient. The erosion of the cone shell can also cause the teeth to loosen and fall off. Sometimes, it is because the cone steel is too soft, the cone has not been properly heat treated, and the fixing force is insufficient. After heat treatment, the core hardness of the gear is too high, so that after the alloy teeth are pressed into the tooth hole, cracks will appear around the hole, and the tooth fixing force will decrease. The whole wall is damaged because of the wrong tooth pressing angle. 4. Tooth breakage or fracture. Common forms of blunting of cutting structure are cracking and breaking. Common forms are fragmentation and fracture. Fragmentation means that a small part of the tooth is broken. There are 3 basic factors that affect the speed and degree of fragmentation and fracture. Formation factors, operating factors, drilling pressure speed, and drill bit selection. Causes of particularly severe tooth breakage and chipping. For steel tooth three-cone drill bits. 1. Improper selection, the formation is too hard. 2. The drilling pressure or speed is too high. High drilling pressure can easily cause the inner and middle rows of teeth to break. High speed can easily cause the outer row of teeth to break. 3. There are fallen objects at the bottom of the well. 4. Improper steel used or improper heat treatment. For insert tooth three-cone drill bits. 1. Wrong selection. 2. Bearing failure. Cone fight. 3. Improper fit between teeth and tooth holes. Teeth can rotate in the tooth holes and cause broken teeth. 4. Defective alloy teeth. 5. Too high drilling pressure and/or speed. 6. Collision with the well wall shoulder or the bottom of the well when drilling down. 7. There are fallen objects at the bottom of the well. Wear of the outer edge of the palm back. Wear in most cases occurs after the bearing fails. The bearing fails and the cone moves outward to the center of the drill bit, causing the outer edge of the palm back to lean against the well wall. And the palm tip will also contact the well wall. Other reasons for the wear of the outer edge of the palm back are 1. Too much rock debris at the bottom of the well, poor bottom cleaning effect. 2. Eccentric operation, causing more wear on the palm back of one or two teeth. 3. The well is too inclined. 4. Use downhole motor, poor bottom cleaning effect, and high speed. 5. The coaxiality of the drill bit is out of tolerance. 6. The quality of the palm tip welding is poor, then the reason may be related to the abrasiveness of the formation. The drill bit model and the drilling parameters. 6. The center of the drill bit is worn out. The teeth in the center of the drill bit are worn or broken, so that the corresponding formation at the bottom of the well is not cut and the rock is left. The reason is roughly there are 1. The abrasiveness of the rock formation exceeds the wear resistance of the center teeth of the drill bit. 2. The teeth fall off after the cone shell is eroded. 3. Metal debris at the bottom of the well causes the center teeth to break. 4. The shape of the bottom of the well changes greatly, and the measures for repairing the bottom of the well after replacing the new drill bit are improper or the time is too short. 6. Cone breakage. Cone breakage means that the cone body is broken into two halves or several pieces, but most of the cones are still on the drill bit. The cone body breakage can be caused by many reasons. The main reasons are 1. The cones fight. After a bearing fails, the cones roll over each other and cause one or more cones to break. 2. Drilling and drilling slipping cause the cone to be subjected to severe impact. 3. Hydrogen sulfide corrosion in the well leads to hydrogen embrittlement. 4. Improper heat treatment causes microcracks in the cone housing. When the drill bit is working, due to fatigue impact load, the cracks expand and cause the cone to break. 7. Seal failure. The O-ring of the bearing often fails due to grinding and heat. The failure of the O-ring of the bearing is the most common cause of bearing failure. The reasons for seal failure are 1. The drill bit is stored for too long and exceeds the shelf life. 2. When the drill bit is stored and used, especially when the eye is reamed, friction heat is generated between the drill bit and the well wall, which is affected by the friction heat generated between the drill bit and the well wall. Heat affects the aging and failure of rubber seals. 3. Drilling without sufficient circulation of mud. 4. Excessive drilling pressure and speed combination, especially too high speed, will cause bearing seizure and seal failure. 5. The palm tip is too thin, scratching with the drill bit, hitting the well wall and falling objects in the well, and the palm tip is severely eroded, which will cause the palm tip to be damaged and the seal ring to be exposed and damaged. 6. Abrasive particles penetrate the gap between the palm sealing surface and the bottom plane of the cone and invade the bearing seal ring, causing the seal to fail. 8. Bearing looseness. Due to the failure of bearing locking and the wear of the cone shaft hole, the bearing loosens. Main reasons: 1. The locking steel ball breaks and falls. 2. The retaining ring breaks and breaks. 3. The seal fails and the bearing wears. Understanding the failure causes and manifestations of 3-cone drill bits will help improve operating efficiency and safety. In the future, our Deris drill bits will continue to explore technical means to ensure the efficient performance of 3-cone drill bits and contribute to oil and gas extraction.